Hello, everyone. Welcome to part B of episode 3 of the webinar series, where we talk about how an enterprise can leverage the vast resources of AI algorithms to become more data-driven. Okay, so just to recap, in our previous episode, we introduced the concept of classification and we looked into the basic operating principles of logistic regression. We looked into the idea of logistic regression and also took a look under the hood that how the model is defined and how uh, we go from linear regression to logistic regression that gives us a classification. Okay? And we also work through the model equation. And today's episode, we will do a detailed workout example of logistic regression. We will uh, use a notebook to actually go through each steps of the logistic regression, how to build a logistic regression from scratch using classification data, and how to interpret the logistic regression models. In the next episode, we will look into some practical aspects of logistic regression, meaning that we'll look into how the logistic regression models are trained and how to understand the model and how to evaluate those models. Okay, without further ado, let's move on to uh, this Colab notebook that we have provided. So if you click on this link, we should go to this Colab notebook. Okay, so this notebook we will share with all of you, and then here we'll use the breast cancer dataset for doing for building the classification models, and you can read more about this. This dataset is as part of a Kaggle competition, and so let's run through this code. So for this particular code, we'll be using NumPy and scikit-learn, sklearn, which is a part of a Python package that provides access to all these machine learning models. We'll be looking into sklearn a lot in the coming episodes. Okay, so as part of the sklearn data sets, okay, the breast cancer data that we'll be working on, it is as included as a part of this. And then when you say data sets that load breast cancer, then this data is available to us. And if we take the data and the target of this data as X and Y, then we get this X and Y values. And if you look back to our previous discussion, this X is our features and Y is our basically those are the target variables. So basically we'll have some features as we will look into later. So this data set is providing us with some aspects of radiology, some features that are extracted from radiology images. And from there, some of those mammograms were marked as abnormal or having cancerous, and some of them were marked as normal or benign, right? And this model tries to learn that what out of these features, right? What of these features corresponds to some of these mammograms being abnormal versus some of them being normal. Okay. So if we look into this overall data, it shows it has bunch of properties of the data, and it has the description, and then it has some features, and it has some description of the feature values, right? And then it has the data part where actually that's what we copied. Data.data and data.target are the two values that we copied from this data. And data.data is an array of some feature values, and data.targets is an array of zeros and ones that tells you whether this is a zero. Here means that it's a non-cancerous, and one means it's a cancerous. And the feature names, if we look later below here, data.feature name, if we print them, then we see that it has the radius of the lump or the tumor, and the texture and the perimeter and the area, smoothness and compactness, concavity, and concave points, and symmetry. Okay, so those are some of the mean values, and then there are some error values. So there are, okay. So if we look at the description here, there are a description, then we actually see that it tells you exactly what the attributes are, radius, texture, or the description of everything. So basically, now what it comes down to is that we are given 30 features of particular mammogram properties of a tumor, and then we have some labels whether that corresponds to a normal or a cancerous tumor. And we want to learn a model so that we can predict. We'll see whether the machine learning model can predict using these features. And for that, since like you can model this problem as a classification problem, you have some features and then you have to predict a discrete value, zeros and ones. So that's why it's a classification model. And then we'll be using classification algorithm. And if you recall from our episode 2, is that when we have some data, it's always like a good idea, and it's a standard practice to randomly shuffle your data and then take a portion of your data for your training, and then keep set aside a portion for test data. So we use sklearn's train and test split. That's a function that's provided, so you can just use that. So if we run that, then we see that the data set is now divided. The x and y that we collected before is now divided into x train, x test, y train, and y test. Okay, and then here we are doing a split based on 80-20. So test size is 0.2, means 20% of the data will be set aside for test, and we'll be building the model on 80% of the data. So if you look at the number of rows and number of columns, right? So for the training data, now we have 455 rows, and rest of the data is set aside for test. Okay, and there are 30 columns, as I said, right? So now we are building a logistic regression model, and if you recall from our previous uh, um, episode where we described the basics of logistic regression model. So we said that for each feature, the model is parameterized by a weight, right? So for each feature, we have a weight. So since we have 30 features here and one output, right? So, and for each of these features, 30 features, we'll be learning weight. So for each feature x1, x2, up to x30, we'll be learning a weight called all of this sklearn or scikit-learn models. They follow the similar interface where you use this, you create a classifier and then or a model, and then you just say dot fit and give x train and y train. Here basically you are giving the training features and training labels, and the model the fit dot fit actually does the model training. Okay, now if we want to look at some of the details of the model, so if you just look at the classes of this model, it's zeros and ones. And the model has already learned. So if you look at the model intercept, right, we see that the beta zero coefficient for this model, which is a special variable, it's called intercept, is 0.24. And then if we look at the other coefficients, so then we'll see that it has learned 30 coefficients. Some of the coefficients are large, some like positive values, and some are small values. So basically, now going back to our previous episode, this model, right, makes a probability based on, first it computes the term beta 0 plus beta 1 x1. So beta 1 is this value 1.27, and x1 is, for that particular case, what is the feature value, right? So x1, if I go back and look at this, x1 corresponds to the radius of the tumor, right? And it has some value. So whatever value is there, we multiply it by this coefficient and so on. So for all 30, take the exponential of this, meaning that we do a e to the power negative of that number, right? So if that number is greater than 0.5, then the model says it has a probability of so 0.5 is the default threshold here. So if that number is greater than 0.5, then the model predicts that it is a cancerous. If it's less than 0.5, then it predicts it's to be 0, meaning that it's a normal. Okay. So now here this one's right, the worst radius has the largest value here. So basically, I believe this 1.33 corresponds to this feature 1 worst radius, meaning that the value of the worst radius, like worst value of the radius, okay, is the most predictive feature for predicting whether a particular scan is cancerous or not. Okay, and yeah, so then if we take the test values, okay, then we see that the model makes the predictions on our test data set. Some of them it says should be 1, some of them should be 0. Okay, so in our like, and you can also create a single test case. You can take one case and then say classifier is our model name, right? If you remember from the previous thing, that okay, so the model that we build is called classifier, then we fit it. Then if we send our test data set to that, it can do a bulk prediction, or you can get prediction of a single test case, whether it's 0 value or 1 value. So, and then if you look at the test case 1, right, you'll see that these were the values, and for this particular test, if there is a function that scikit-learn provides, it's called predict underscore probabilities, right? Predict probabilities, and if you send a test case, then this will give you the probability distribution of being in case 0 or case 1. So in our test case test set 1, right? This model thinks it has a 99% chance. This has a 99% chance to be of class 0 and a very, very low chance of being in class 1. Okay. So in our next lecture, we'll be talking about the evaluation of these models, and we will also talk about that we'll look into how to interpret these coefficients, right? So what does a value of a coefficient, high value of a coefficient means, right? And thank you very much for listening to this webinar.